Ganon. Okay. Electromagnetic force. Electromagnetic force. Okay. So in our board exam before, I remember what came out is the inductance. Okay, inductance. Okay. What is inductance all about? Okay, what is an inductance all about? Okay, inductance is simply the reciprocal of resistance. The reciprocal of resistance. Okay, now if you have the Ohm's law, okay, Ohm's law, that is very famous, right? We have the voltage is equal to the current times the resistance. Then we have the resistance is equal to the voltage over the current. Then, since we are saying that it is a reciprocal to the resistance, then we can say inductance, let's say inductance IN is equal to current over voltage. You will just reverse the formula because the statement in the theory says it's the reciprocal of the resistance. You get the point? Now, what is the unit of measurement? Unit of measurement of inductance. Okay. Now, if you have the ohms, okay, unit in resistance, am I correct? I like this, omega symbol, Greek. Omega, just like theta, phi, rho, epsilon, like that. Omega, micro, like that. Greek symbols. And then this is omega, this is ohm, OHM. Okay, or ohms if that is too huge. 1 ohm, but if more than 1 ohm, it will become ohms. Grammar, right? Plural and singularity. Plurality and singularity of term. Okay? Like that. Now, if I say the reciprocal of the resistance, so I will say also 1 over ohm. Or in math, you're gonna say ohm raised to the power negative 1. It's just the same as 1 over ohm. Okay, what's unique for this inductance is you also reverse the letters. And this is amazing because this is only based on my study in my entire 5 years of education in chemical engineering of CIT University. This is the only unit in physics that you would try also to reverse the letters to become the unit of inductance also. For example, if you have the ohm, you will reverse the letters. You say M, H, O. This is also the mho. The mho is also the unit of inductance. Amazing, right? The reverse of the letters also the unit of inductance. From ohm, it will become mho. Just reverse that, put in your brain cells, that will be automatically the unit of your inductance aside from 1 over ohm or ohm raised to the power negative 1. And take note, there is still another unit for that, which is the most, I think, most commercialized unit in the mobile technology brand. Actually, this is becoming popular, the same as Motorola, LG, something like that. This is Siemen. Okay, Siemen is a brand of technology, but this Siemen term is derived from the unit of inductance. That is a unit of measurement of inductance, the reverse of resistance. That's why we have a Siemen brand of mobile phone, laptop, something like that. So 1 Siemen is equal to 1 mho. It's equal to 1 over ohm is equal to raised to the power negative 1. Which is which of the 4 units? Don't be confused. Okay, it's just the same. Okay, that's inductance, right? Now, we go to another topic. Okay. We go to elastance. What is an elastance? Elastance came out in the board examination, which is not popular. Okay? So in mean of elastance, that is also the reverse of the capacitance. Okay, disclaimer, I'm not an electrical engineer, but I'm just keep on researching about that, though we have the same common subjects. We have also practical electricity subject. All engineering courses have practical electricity subjects, but only the basics, only not the deeper. Of course, the electrical engineers will go the deeper for their major, but for us, we have universal practical electricity subjects. So we mean of basics, we can understand also, all engineers. Okay? Or all engineering disciplines. Okay, now, so we have conductance, right? Conductance. Okay, so we need to discuss first the conductance, right? What is a conductance? Nakakaloka. What is the conductance, mga palangga akong hitan? Ang sama niya siya. Okay? Ang conductance na, paano ka? Mukhaan ko. Nakakaloka. Okay? Ay, nakakaloka. Partly a reciprocal to resistance. Or the reverse of the resistance. Okay. Yan siya. And then, number 2, capacitance, right? What is a capacitance? Let's say we have a capacitor. Okay? So the root word there is a capacity. Meaning the loading of your electrical circuits, like that. The loading, you have to put load. That's why how much capacity it will be having. So that kind of material has the tendency to accept how much total of the capacity. So capacitor, right? So that is capacitance process. Okay. So capacitance is the ability to store energy. See, store energy because it is capacity. Okay. So, ability to store energy, okay, in the form of electric field. Okay. So, an electric field really is a physical field that will have an equivalent force or forces in between those electrically charged particles so that it can create an electrons flow, and thereby you can produce a current or an electricity. So it is a field, something like that. So what do you mean by a field? Oh, soccer field, cricket field, basketball field, volleyball field. So it is a region or a place or a location in which there's certain movement and velocity of your electrically charged particles. Okay? So that you can create an electricity or a current. Okay? Get the point? Like that. So, electric field. Ganon. Okay, muna siya itong capacitance. Okay. What is the formula of a capacitance? Ako ginahinay guys because this is quite a little bit complex na talaga siya. Okay? Because it's far from my specialization. Okay? Capacitance, not really that far, but you know what I mean. Okay, capacitance is equal to, okay, the source, okay, charge. The source charge, the capital Q, okay, meaning column ni siya, kay charge man siya unit, over the applied voltage. Applied voltage in DC, direct current. Okay, not the alternating current, but the direct current. So it's gonna be source charge, meaning column, that is column, okay, per, this is voltage, volt. So the unit is column volt for the capacitance. Okay, that's the first unit. Okay, what is the second unit for this capacitance? We have also another unit, which is the farad. Due to Michael Faraday, a scientist who discovered this year, something like that. Okay, small f which is 1 farad. Okay? Like this. 1 farad. Farad lang siya. Okay, 1 farad, F-A-R-E-D. You will never abbreviate this one, ha? You will write all the term farad. Or if you want, abbreviate that to F, but it's better to put the word farad, okay? So, 1 farad is equal to, this is quite complex na, because there are 4 units in a single unit. There are 4 quantities in a single unit, something like that. It's gonna be seconds raised to the power 4, like that, an ampere raised to the power 2 over the mass in kilogram times the surface area, okay, raised to the power 2 squared. Now, don't be confused with the A and the meter squared here. In the denominator, this is the surface area, capital A ba siya? The capital A here is the ampere in the numerator, not the area. Okay? The area is in the outside, but meter square. But capital A, the numerator is the ampere. And you can also understand because this is in terms of electricity. So the A, capital A, will always be the ampere. Okay? You get the point? Ganon-ganon. Okay, mga palangga. So this is the other unit of a farad. Okay, you get the point mga. So farad is a unit of a capacitance and also coulomb volt. Ganon. Since if you try, for example, 2.8 farad, convert that to coulomb volt, then you can also get, because it is related or equal. Something like that, okay? Ganon. This is the capacitance. Charot. Okay. Now, what is an elastance? Elastance, the root word is elasticity. If you try to put that in a wire, like a rubber, like the principle of a rubber band, you try to stretch. Okay, but not necessarily a rubber you stretch. For example, a rope, a wire like this and everything, because it's related to electricity, right? If you try to pull or stretch that one, you can achieve an elastance, which is the reverse of capacitance. Okay? The reciprocal of capacitance is the elastance. Okay. Now your formula also will be reversed. It will become now volt per coulomb. And it will now become also kilogram meter squared s to the 4 seconds for a to the 2. So all you have to do is to reverse the units and you can understand now. Okay? Because it's simply the reverse, right? Just like specific volume. Specific volume is the reverse of density. Like that. Okay? Because when we mean of specific, there's always mass in the denominator. It's gonna be specific volume. Ganun, so cubic meter over kilogram. If you reverse that kilogram per cubic meter, that will become now a density. So meaning to say, specific volume is the reverse of the density. Vice versa. Density is the reverse of the specific volume. Theory. Okay? Something like that. Okay. Now, the unit of inductance, mga palangga, kung hitad, is the Henry. 1 capital H. 1 Henry. So, 1 capital H or 1 Henry, because discovered also by Mr. Henry, okay, is equal to, ganun siya. You try to reverse the unit of the capacitance. Okay, it's gonna be like, anaonin mo siya, kilogram meter squared. But instead of having seconds to raised to the power 4, it will become 2 na lang siya. So, S to the 2, ampere raised to the power 2. This is the unit of 1 Henry. This is only the complex part because there are 4, unit of measure. I mean, it's not easy to memorize. That's why you need to understand the mechanics, how it is being done, like that, the reciprocal, ganun, the related proportionality, dependency and dependency, like that, proportionality, whatever. Okay, so that you can easily troubleshoot. You can easily, this is wrong, this is correct. Because our memory is not 100%, okay? Especially when we are now aging. Okay, age. Factors that could affect the declining of the memory. One factor is aging. Okay, like that. Okay. So, muna na siya. Okay. So, the statement definition of an inductance is the ability to store energy pa rin, but in the form of a magnetic field. Like that. So, what is a magnetic field? The magnetic field really, guys, is really a field in which there is a corresponding velocity involved in the electrically charged particles moving in that field. Okay? Like that. So the magnetic field is acting a circular path. If you have the conductor to create electricity, meaning to conduct electricity, that's why conductor, right? So after conducting an electricity, the motion and the movement of your magnetic field will be circular path, like that. And then the current will be there, the force will be there, the velocity will be there. So anything, there will be no current if there's no force velocity. There will be no current if there's no force and velocity involved. Okay? Ganon. Wala na siya. Diba? Now, we go to the amazing, not really amazing, the unfamiliar unit. Okay? Something like that. So, let's go first with what is the unit, let's say fill in the blanks, number 1. Fill in the blanks. What is the unit of measurement of, let's say, unit of measurement of magnetic field? Okay, magnetic field, what is? So, since the standard unit for this is Tesla. Okay, Tesla is your answer. Now, Tesla has so many units according to your preference and choices. It depends on the problem that you're trying to solve. As long as you're compatible with the units of measurement in the question that they're trying to ask. Right? So it's gonna be also Newton over meter ampere. This is the first, comma, like that, diba? It's also kilogram second squared ampere. Okay, like that, comma. Okay? It's also farad per meter. Okay? It's also Weber over square meter. Now, with the units here in the units I presented is not common. It's the Weber. Right? Now we go to Weber. Number 2. Weber. Okay? So, the Weber, mga palangga, kung litag, W is the unit of magnetic flux. Very closer. Be careful. Because during the choice, maybe it will be trick you out. Because magnetic field, magnetic string, it's just closer. So, unit of measurement of magnetic flux. Okay? Magnetic flux, something like that. So, kung magnetic flux, Weber. Kung magnetic field, Tesla. And these are all standard units in SI units. Okay? Or metric system, something like that. Okay? Now, Weber has also its equivalent. Okay, we'll say 1 Weber, I think there are 2. Okay, 1 Weber is equal to 1, ganon siya, coulomb per second. Okay, and then it can be converted also to volt per second. Okay, like that. And then the special one, equivalent to 108 Maxwells. Diba? It sounds unique. 108 Maxwells. O diba? O, narinig nyo na ba sa iba ito? Sa akin lang, diba? 108 Maxwells is equals to 1 volt per second and 1 Weber. So, I am unique. Charot lang. Okay? So, that is the unfamiliar unit. So, 1 Weber is equals to 1 volt per second and also equal to 108 Maxwells. For example, I have 2.38 raised to the power 26. How many Maxwells? Nga. Because you don't know what's the value of Maxwell. Now, the last resort is you need to scan the book, like that. If no open books, nga. There's no open data in the examination. No allowed internet. Okay? It's only your memorization will work. Okay? For example, calculate 8.5 million volt per second into Maxwell. So gamitin natin mo, 1 volt second is equals to 108 Maxwell, then i-convert mo din, pasok sa banga. Ganon. Okay? So, naka-idea na 108 Maxwell siya ang 1 Weber. 1 volt per second. Ganon. Now, another, shut up. Okay, so we have, what is the unit of magnetic flux density? Wow. So, the only difference, guys, is you put density after the magnetic flux. Okay, since density is really an intrinsic property, right? Intrinsic property that does not depend on the size of the sample. Okay, like that. Or the nature of the sample. Okay, that is intrinsic property or extrinsic property. Types of physical property, right? Intrinsic property and extrinsic property. Intensive property and extensive property. So density is an intrinsic property or an intensive property because it is kilogram per meter. There are two units involved, so many things. Chuba chucho. Okay. Now, you're expected also that your magnetic flux density has also a unit which has a numerator and has a denominator. Okay? Something like this is your magnetic flux densities. It's gonna be Weber per square meter. That is your unit of magnetic flux density. Now, take a look in number 3. There are also the same Weber here. Right? That is also the unit of magnetic field, sir. Yeah. So, meaning to say, magnetic field and magnetic flux density will be technically the same. Okay? So, if the problem will say, calculate the magnetic flux density, so if you are not familiar, you will be confused because you are only using all the time the magnetic field. But it has the same meaning. So you can use also the formula of magnetic field to compute for the magnetic flux density. Now, if you don't have an idea, again, nga. Okay? So that's the point. Okay? And of course, 1 Weber per second is also equal to Newton per meter ampere, kilogram squared ampere, farad meter, chucho. Muna siya may tabo. Okay, you got the point. Ano na siya? Any questions so far for this? Okay. Okay, now we go to the electromagnetic force. Total combination. So, total combination. Fairness. Okay. So, okay. Nakakaloka. Electromagnetic, di ba? Okay, mga palangga kong hitag. Electromagnetic force. By the way, ang formula sa inductance kaya, before ko makalimot, inductance is just equals to EMF. Electromotive force, which is a volt, is equal to the changes in the current over the time. Okay? Meaning to say, if the problem solver will say, calculate the inductance of a wire that has an electricity of blah 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 with a time of 3 seconds, and you don't know, you're not familiar with the inductance term, right? So this is gonna be, it's just the same with the EMF, a charge. No, it is the changes of your current or induced current, meaning varying currents, something like that over the time in seconds. So this is your inductance formula. Okay, ganon. Okay. Now electromagnetic force. Sama ni siya. Electromagnetic force is equals to electric force, okay, plus magnetic force. Okay, and electromagnetic force is all about another term, Fury. This is also called as a Lorentz Force. So by now, we need a lot of forces in our brain cells. We have the 4 fundamental types of force. For example, guys, if the question in the future will ask you, or for example, if you're joining science competition and then the host will say, what are the types of fundamental forces? Think. There will be weak nuclear forces, strong nuclear forces, electromagnetic force, and gravitational force. And I thank you. Ganon. So that is the 4 fundamental types of forces. Who knows, there's a question like that, enumeration, in the Battle of the Brains, in science quiz book, science quiz fair, if you're also experiencing like that in your past, right? Okay. Okay, but that was very enjoyable during that kind of competition, guys, ha? Okay, so that's to motivate you guys. It's very, very enjoyable. Okay, to the point. Ganon. So it's gonna be the Lorentz force is the combination of all forces, okay, that acts through the electrically charged particles. Again, electrically or between electrically charged particles with a corresponding moving velocity through electric field and magnetic field. Okay? So, if you say electric force, automatic there will be an electric field. If you say magnetic force, automatic there will be a magnetic field. Ganon. Okay. Now, we need to break the equation. Electric force, what is the formula of electric force? Break the equation. Ganon, di ba? So, sama ni mga pagpasok sa banga. So, you're gonna be like, the source charge times the test charge times the, okay, electric force constant. Okay, mga palangga. Electric force constant is just the same also with electrostatic constant. It's also the same with electromagnetic force constant. It's also the same with Coulomb's law constant. So there are four terminologies for that constant K in your electric forces, and the examination will always use that interchangeably according to their preference. Sometimes you will use the Coulomb's law constant, blah blah blah, so on, so blah blah blah. Sometimes you will use the electric force constant, blah blah blah, blah. Katong 4, ikon-kuan to siya. Basta K na siya ni. So K is equal to Q times Q. Q is the test charge variable based on experimentation on your devices used to test the charge. Diba? Common sense. And this is the source charge, meaning the source is your parent charge, that is the main source. You will never touch that because that is your main source of the charge. Okay, then over R squared. R is the distance between the source charge and the test charge, and that is actually the separation distance between them. Okay, R squared. This is not the radius but the distance. Okay, then ganon siya. Hindi tapos mapalaga kong hitan mo na siya may tabo ng higayuna. Okay, now plus magnetic force. What is the formula of magnetic force? Okay. The formula of magnetic force is the charge also with a corresponding velocity, and there's like a bar like that because the magnetic field will act on that. Then times the capital B. Actually, guys, this is the standard formula of the electromagnetic force or the Lorentz force. But sometimes you need to take note, guys, because beside the B, this is the magnetic field. This is not the magnetic flux, but this is the magnetic field. Okay, magnetic field or the magnetic flux density. Okay, the magnetic field. Okay, ganon. Okay, now sometimes, guys, okay, apply to nimong cosatowa, yung Pythagorean theorem. If your charges will, as I told you, will go to the top, will go to the right, the left, something like that. So you will use the law of right triangle of Pythagorean theorem also. Sometimes na siya tupad na sine theta. Why sine theta? If we draw that here. So we have here our, for example, our magnetic field and an angle theta, something like force and our velocity, something like that, right? Now, who drives the magnetic force? Of course, this force here at the perpendicular. Kaya nga magnetic force because the one who drives the movement of magnetic field is the magnetic force, and the motion will be also in that. Now, so what do you mean by sine theta here? Okay, because this is a parallel to the horizontal axis. Okay, like that, parallel to the horizontal. So this is the opposite side also. Okay, opposite side also. Ganon. Now, okay, since the force is vertical in your drawing for the magnetic force, force is vertical, then you know, you draw an imaginary line here also, parallel to your triangle. This is your theta. Di ba? Kung ano siya? Sa. Kung sa towa, sa. Ano siya? Sa. Okay. Now, this electric force, you will transfer that here also in your imaginary. Right? So that's why you will say, sine theta, okay, ganon, F over B, magnetic field. Ganon. O, diba? Ana siya. You get the point, mga palangga kong hitad. Okay. Now, since that is a 90 degrees. Okay. And then sine theta. So, sine of 90 degrees. Okay. Because this is 90 degrees, right? And sine, really, because this is parallel to your force. That's why we use the sine. Okay, not the cosine. Get the point? Okay, cosine, kanina man siya ang cosine. Sen theta man na siya dalaara. The sine, adjacent, hypotenuse. O ganon. Okay? So ano? Sine, kay parallel man siya. Usada yun. The 90 degrees. Di ba? So sine 90 degrees. What is the value? Calculator. Sine of 90 degrees. See, it's just equal to 1. That's why you don't put sine theta anymore here in your magnetic force nga. Q, charge plus velocity times the magnetic field times the sine theta. Because the sine of 90 degrees will always be equal to 1. You get the point? Because you can establish 90 degrees here of your low right triangle. Right triangle, I'm 90 degrees for the Pythagora. That's why we don't emphasize anymore the sine theta here. Because the sine of 90 degrees is also equal to 1, the same as not to put a number beside the magnetic field. But sad to say, the book will not explain like that. You will always see like this directly. Sometimes because there's no teacher helping you and guiding you how to understand, right? Sometimes it looks like a magic, something like that. Okay, and you have to dig deeper, something like that. Now, if this is not 90 degrees anymore, so that's the time you will use sine theta here. You say 25 degrees because it's variable already, except for 90 degrees because it happens that sine of 90 degrees is just equal to 1. Especially if it is parallel to the x-axis. Okay? Ganon. So, we will just use, in the benefit of the doubt, the sine theta lang talaga siya. Okay? You get the point? But if there's no involved angle of in your problem, so forget the sine theta. Okay? But if it's very obvious that you can create a triangle, a rotation, revolution, okay, then you have to put sine. Especially one revolution of the blah 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 so and so of the centrifugal pump, like that, ganon. Okay? So, well, this is the general equation. Okay. Now, this magnetic force palangga, because this is the magnetic force acting on the moving velocity between the electrically charged particles. This is the first version, electrically charged particle with the corresponding velocity. We have also another magnetic field acting on the current carrying a wire, which is another version. Sa mga cable, electricity, the process like that. So the magnetic computation, the magnetic force computation is another story. So we have here, it's gonna be like force times current times the length of the wire or a coil, something like that, or anything that will conduct electricity, okay, times the magnetic field, again, times sine theta. Okay, the same story. If you can have 90 degrees, based on your problem, sine of 90 degrees is possible. You don't need to put sine anymore. But if that is more varying angle of inclination, then you have to put sine theta. Okay? So this more siyang another version. So be careful also, because this is through wire already. You get the point? Ganon. Muna yung tabo. Okay. Now, there's also another version of the electric force. You got the point, mga palangga? Okay? Nasa siya, katunglain sa siya nga. I will show you. I will derive something. Okay, let's check for the electric force na lain siya nga version. Dili sa katong test charge, source charge, ng ganon. So, for example, if I have an electric field is equal to the electric force over Q, electric force F, Fe over Q, mga ganon, chuba-chucho, diba? Ganon. Okay, now, electric field is equal to the force times 1 over Q, right? Transpose that to the other side. And we know also the force in terms of electric force is equal to K, source charge big Q times the test charge small q, okay, over the distance of separation among charges raised to the power 2 times 1 over q. Then do the math. What is common there? The test charge. You can cancel the test charge. And what will be left? Electric force like this. Okay? You get the point? So, electric field. Ganon. Di mo man yung force na nahigayuna. Hindi mo man siya i-cancel. Whatever. So, manalo yung electric field na nahigayuna. Now, muanak din ka mga palangga. Kina-cancel naman yung manalo yung electric field. Electric field is equal to KQ over R squared na lang siya. Okay? Then, how to compute for the force? O, balik na ko na yung formula. E is equals to force over Q. Ganon. So, ipasok na sa mo sa banga. Makakuha na sa kag-force. Okay? Force is equal to KQQ over R squared. Ganon, chuba-chucho. Okay? Ganon. Now, take note another version pa, John. If that is will be rotating in a 360 degrees Celsius, then you will treat your electric force as a centripetal force. Right? You will see also, electric field is equals to mass times the velocity squared over the radius squared and the squared over r. And then over q. Ganon. O diba? So, ano talaga makuha ng dara? So, it will become E is equal to mv squared over rq. So, use the substitute also in this formula here. mv squared over rq. Ganon. Plus FILB sine theta. So, the electric force has so many versions. Versions in terms of electric force. Version in terms of the centripetal force. Version in terms also with the second law of Isaac Newton. Electric field is equals to the electric force over the Q, the charge. So, our force is also the same as mass times acceleration in the second law of, motion. So, it will become ma over q. Then put that also here. Ma over q plus FILB sine theta. Another version last. Through also gravitational force in the third law of Isaac Newton, the law of interaction, that in every action there must be always equal and opposite reaction. The example for this is the law of the free fall body or free falling body into the Earth's surface. So F is equals to mass times the gravitational field strength, and then or acceleration due to gravity over the Q. This substitute also here in your electric force. Okay, ganon. Okay? You get the point? As long as mapasok kasi siya sa banga sa imong electric force, imo din na siya ni sulod-sulod rara. Okay? Ganon. Okay? And then mga siya mga formulas, whatever. But to be honest with you guys, it's only seldom and rare to combine the two. Usually, the problems will only focusing on the magnetic force only, and then electric force only. Usually separated. There are only a few instances or rare situation that the two will be combined in a problem solving. But you should also not take for granted. Maybe have also like that in the future. We don't know because expect the unexpected. Okay, get the point. Anak mo na siya mga examination. Expect the unexpected. Okay. So, any questions so far? Nothing? Wala na ta mga palangga kong hitad. So thank you so much for watching. I hope you like this video. Okay, and I hope also you can share to anybody else. You can like, you can comment, anything like that. Okay, and let's observe professionalism when we comment. Okay, and then subscribe to my YouTube channel if you want, and I will be grateful to that also. And you can click the notification bell for some newest updates of I Am a Singer, Eternal Voice. Then we will be able to solve one more problem, I think. Okay, so thank you so much for listening. Remember, Jesus loves us and Jesus loves you. God bless everybody.